Hi everyone, my name is Lakot Yang. Today I would like to present our final group project titled Animal Sounds Recognition, and which means an AI approach for wildlife monitoring by using the Google Teachable machine. First, I would like to introduce our group member. They are Hugh Hao Nam, Mubin Bin, Muhammad Rahiman, and Alif Adam. Next, I will explain why we decided to build this system. The main reason is that wildlife monitoring in large and difficult to access environments is challenging. So traditional observation methods require a lot of time, manpower, and resources. Besides that, direct observation may disturb the animal and affect their natural habitats. So we propose an AI-based system that can automatically identify the animal through their sounds. Moving to our introduction parts, there are three main problems that we have faced. Firstly, the monitoring animals in remote areas is difficult and may cause gaps in information about the animal populations and behaviors. Secondly, the traditional manual observation is labor intensive and requires continuous human involvement. Lastly, current monitoring methods may disturb the animals, making it difficult to observe them naturally. Hence, this project aims to develop a smarter wildlife monitoring solution. So next, the objective of this project are to identify the unique acoustic patterns of selected animal species. Secondly, to develop an AI audio classification model using the Google Teachable machine. The last is to create an automated system that identifies animals from audio inputs without disturbing their natural habitat. For SDG, this project refers to SDG 15. They are the life on land, which focus on protecting the ecosystems, conserving biodiversity, and reducing the biodiversity loss through sustainable approaches. Furthermore, for our project scope, we selected five target animal species for monitoring, which are Malayan tigers, Asian elephant, Bornean orangutan, Borneo pony, and the helmeted hornbills. This is the picture you can refer for the animal. Next, I want to pass to Hugh Hanan to complete his part. Thank you.
Hello, my name is Yohanam. For my part of the presentation, I will walk you through the methodology of our animal sound recognition system, starting with our model development. Our system was built using an interactive process that we divided into four main stages. First is data sourcing. We built the foundation of our database by obtaining raw audio clips of target animal directly from official online repositories. Next is class initialization and data translations. In this stage, we establish distinct category for our target species alongside with a mandatory background noise class, which sets the ambient baseline of the environment. Third is the training phase. Using Google Teachable machines, the system automatically converts the raw sounds wave into 2D visualized representation called spectrogram. The underlying convolutional neural network or CNN then processes this spectrogram to learn the unique acoustic pattern of each animal. Finally, export and deployment. We validate the model on the Teachable machine webpage using isolated test audio that was kept completely separated from the testing data set. The system then outputs a precise confidence percentage, allowing us to evaluate its accuracy. Next is data collections. First, difficulty. Gathering live data from endangered species present extreme logistical and safety challenges, which make direct recording out of the scope of this project. To overcome this limitation, we'll be using a verified open source repository for the data source. We collect audio source from primary source like the Macaulay library and structured data sets from Kaggle. We also supplement our data using educational and organizational libraries such as the SeaWorld Animal Sounds Library and the Wikipedia Open Audio. Last, pre-processing phase. Because raw files vary significantly in clarity and length, we apply the strict pre-processing phase to ensure uniform feature extraction for our model. this involving two main steps. First, acoustic isolations, which trim away irrelevant stretches of silence or non-target sounds. Second, noise migrations, where we filter out unrelated environment clutter to ensure the model extract clean and class specific features. And that will be all for the
Hi,
methodology.
my name is Mumbin and I'm here with my friend Alif Adam. We are here to demonstrate the model of Google Teachable Machine for our AI project. As you can see, the model is already trained with many sound samples such as background noise, Malayan tiger, Asian elephant, Borneo orangutan, Borneo pony, and helmeted hornbill. These are all the species that we are working on. And this is the settings that we used to train the model. We are using 50 epochs. So I'll move on with the demonstration of the sound of lion tiger. Another sample. Okay, as you can see, the model is quite accurate. Just now, for the accuracy of the tiger, it went up to like 90%. But for the other sound sample, it might not as accurate as the first one lah, because the AI might confuse about between the sounds, between the tiger sounds and the background sounds. Next, I will move on to the sound of the elephant. Here's the first sound. Second sound. Okay, as you can see, the accuracy for the second sound sample is more accurate than the first one. This is because the first sound sample, it sounded almost the same as the Borneo pony sound sample because of the high frequency and high pitch. Next, I'll pass to Alif to continue the three other species.
Okay, thank you, Pimpin, for the presentation. Now I'm going to show you the other three species that we have worked on, which is Bornean orangutan, Borneo pony, and helmeted hornbill. Now I'm going to play the sound for the Bornean orangutan, and let's see if the machine detect or not. So the machine can detect it almost until the 100%. Now I'm gonna move to the Borneo pony, which is the same as the horse. So for the Borneo pony, the sound is quite short, but the machine can easily detect it. Okay, now for the last one, which is the hornbill. That's all for the helmet hornbill. My conclusion is the method hornbill is the easiest for the machine to detect. As you can see, when I play the song, the machine detected helmeted hornbill is 100% very consistent from the start until the very finish. Yeah, that's all for me. Thank you.
The next part is conclusion. This project delivers a non-invasive automated machine learning solution to wildlife monitoring, overcoming the high cost and habitat disruptions of traditional fieldwork. Testing proved our AI-powered web tool highly effective at classifying distinct species like the Asian elephant and Borneo orangutan, while highlighting future improvement areas for low-frequency calls. Ultimately, this client-side application provides a viable, risk-free tool for conservationists directly contributing to UN SDG Goal 15 Life on Land. Next part is acknowledgement. This research was supported by the Faculty of Information and Communication Technology at the MKU 10. We express our sincere appreciation to Dr. Najwa Ayuni binti Jamaluddin for her invaluable guidance throughout this AI study. Special thanks to the curators of the Macaulay Library, Kaggle, SeaWorld Animal Sounds Library, and Wikipedia for the bioacoustic datasets vital to our model training. And lastly, this project represents the dedicated collaborative effort of Group 76. That's all from us. Thank you.